This video will briefly discuss how to use model selection in deciding which independent variables to keep in your linear regression. So I'll go to Regression Linear. I have my dependent variable to be classroom organization. I have my 4 independent variables, potential independent variables. When I normally come in here, this says enter, which means I'm going to be forcing all 4 of these into my regression model, whether they're statistically significant or not. Once I switch to forward, it's going to do a series of models, which I will demonstrate. So I click paste, find the syntax, highlight, and run. And here is my output. What SPSS has done is it's looked across all 4 of the independent variables and found out which one of those independent variables accounted for the most variance in the outcome. In this case, it was behavior management mean scores across all cycles. That R² was about 0.816. And we can see that model here. This is simple linear regression with just behavioral management in the model. Then SPSS looked at the remaining 3 potential independent variables and says, in the presence of behavioral management, which one adds the most to the R²? And it tried all the models and found that the positive climate mean was the best one to enter next. And that increased R² by about 0.04 points. And that's what we can see here, this model 2. It has both behavior management and positive climate means. At that point, SPSS said, do the remaining 2 independent variables, and those are going to be negative climate and regard for student perspectives, do they add significantly to the model? And the answer was no. They were not adding significant predictive power to the model as measured by R² or the F-test. Therefore, they were excluded, and the model forward selection stopped. The final model that forward selection has chosen for me is these 2 variables right here. Now let me show you the same thing with backwards selection. Backward has the same idea, but does it, well, backwards. Instead of adding 1 variable in all at once, it's going to enter all the variables at once and then eliminate the variables one at a time if they have if they don't add significantly to the F value. So model 1 has all the variables in it. Model 2 has 3 variables in it. Model 3 has 2 variables in it. So model 1 has 4, and then it got rid of 1. Which one did it get rid of? It got rid of negative climate. So negative climate, look at the statistical significance, is 0.845. It is the least significant of all these variables. Therefore, it's going to throw this one out and run a new model. Now this one, it did it again. And it said, of all these independent variables, which one does not add to the model? And this one has a p-value of 0.33. It's not adding to the predictive power of the model. Therefore, it got rid of regard for student perspective and left us with our 2 variable model like we got in forward selection. In this case, both methods ended up with the same model. That is not always the case. Nevertheless, this can be a useful tool when it comes to winnowing down the number of independent variables you have.